Hello and welcome to the third video in the current INAV for Beginners 2023 series. If you haven't already watched the first two videos, go and check those out. If you already have, thank you for sticking with the series. Links to everything I'm going to talk about is down below. The model that we're building out this time is this thing here, the Baby AR Wing Pro, or affectionately known as the BARP. And last time we got to the end of the video and we'd set up all the components, we'd connected them together, and we confirmed that everything was working. The Express LRS receiver was fine, and the GPS was also working great too. So in this video, what we're going to do is we're going to install all of those pieces into this Baby AR Wing Pro and do the final setup. Final setup are things like making sure the control surfaces are working the right way, that we can arm the model, that we can spin the motor. Now, I would always recommend for all the stuff we're about to do, remove the prop. The prop is the very last thing we're going to do before we go to the next video, which is where we'll take this to the field and we will give it a fly. So if you have been watching, thank you very much. Let's go and actually go on the bench and think about how we're going to get all those electronics we've already built and programmed inside this little fella. So here we have our Baby AR Wing Pro. Now this has quite a bit of room inside for all the electronics, and we need to figure out how we're going to squeeze everything in here, because at the end of last time we had set up the flight controller, we had a power cable connected to it, we had the GPS, we also had the receiver, and all this has got to fit inside. However, there are some good and bad ideas when you are doing this, and let's go through those before we actually start cutting foam or firing up the hot glue gun. Now, there is only a couple of things that I've done to this model. First of all, I've actually added a couple of strips of wet and dry sandpaper, both here and at the bottom under the wing. Essentially, it's grip tape. It means that when I throw it, that is where my thumb naturally fits and my finger goes underneath. That means I'm not going to slip. The other big thing I've done here is I have installed the 1S Walksnail unit here in the nose. Now, this is one of the mistakes I think that ZOHD made with this. I think they should have put more thought into this. Now, how I did this, and the reason I did it before I've installed everything else, is because we need to put in all the pieces that we can't move to figure out how close to the CG we are. The way I did this, I put a knife in the back and went to each side and then went vertically to cut out a wedge. Once that wedge was out, then I could see what I was doing. I cut the bottom off the wedge so there was room for the board, and then hot glued in the camera, attached the board, and then cut a little bit of a recess for this heatsink that I tend to like to have on these things, and then use a little Yoo-hoo paw to stick it back into position. Now, the reason that I've installed it like this is because this has to be in this position. It has to be up here. It isn't super ideal to have it this far forward. I think with a little bit of thought, they could have done a much better job on how HD systems fit in here. But the 1S board is great because it is super lightweight, and actually it fits quite nicely. It even has a bit of airflow over it too. The other thing that needs to go in here is obviously going to be the battery. Now, it talks about using a 3S LiPo battery or a 3S lithium ion pack, but you can't use these ion packs, which are the kind of ones where you have the two on the bottom and one at the top, because there isn't room. However, what I found with mine here is that actually there is room. I'm going to put mine in and cinch it down. So that's the battery in position. I can actually, if I find the canopy, get the canopy to easily go over the top. So that means now I have my FPV system in place and I have reasonably heavy battery. Let's check where the central gravity is. Now, the cool thing on this model is the central gravity is molded into the wing. So if I put my fingertips under there, it's rolling forward very slightly. If I put my fingertips right on the leading edge of those, it's pretty spot on. So I can get away with putting some weight behind the CG marks, which are about here. So that means that all the electronics that I'm about to put behind this is probably going to be enough to offset, or almost offset, all of the weight that's needed. Now in here then, let me just move the battery just so we have a clearer view of what the heck's going on, because we know where that has to sit. So here we have the two cables from both of the servos. So they're going to plug into the flight controller. We also have the power cable that's coming from the ESC that's at the back. That's going to be cut and soldered onto the bottom power distribution board of the flight controller. We have an auxiliary power cable that actually we don't really need on this, to be honest. This would have been used to power your FPV equipment, but I think we can get away without using that. And then this here, this 3-wire cable has the red, black and yellow, so it needs the signal and the ground, and as we saw before, there are those two little solder blobs that we need to put this into. So let's just put them out the way for the moment, and now we're starting to see there's actually a reasonable amount of space in here. So let's see how it's all going to fit. Now the flight controller has to go a very specific way round. There's an arrow that's pointing to the front, and I would put it reasonably central in the place, reasonably far forward, just because I want it to be almost in line with the CG and in the center, so it can feel the movement of the plane nice and cleanly. So that's pretty easy. We've got the power cable, which is going to go round like that, so that kind of fits nicely. So that's actually looking like a good start. The GPS, now normally the GPS has an arrow on it. Again, the arrow is used really when you're using the compass. We're not using the compass, so the GPS could quite easily sit up here on this shelf somewhere, so we can put that there. That kind of would work quite nicely. Power cable to the ESC, we're going to need to clip and solder to the power distribution board along with that other cable at the bottom. So that's going to go like that. Okay, this is actually looking pretty reasonable. And then finally, we have the cable for the receiver. Now this is one of the diversity receivers. It actually has two antennas. We want them mounted not both upright, we want them mounted both at 45 degrees, and we could probably get away with having them somewhere at the back here, which would mean the receiver, the ELRS receiver, could kind of go like that, and maybe have one at that side, maybe one at the other like that. Hopefully you can go and see what I'm trying to do with those. That would kind of work. And then the last thing is just the USB connector. That might be one where we can just put it to the side here, really. That actually all fits in really nicely. Now the way that I tend to install this stuff, flight controllers, I tend to use this 3M double-sided foam tape. That's amazingly useful. I would make sure that you clean with a little bit of soap and water to make sure there's no release agent from the mold on here, and then we're going to stick that into place. But one of the things we need to do is we need to connect the last bit that isn't actually connected here, which is this ESC. So what I'm going to do, I'm going to, with a Sharpie pen, just mark which way round all these wires go. I usually use a single dot on both sides, then a double dot, then a triple dot. I'll do that, and then we can unplug this, because I have a rough idea how long everything needs to be here for it to work, because that kind of slides in nicely into that hole. So if my flight controller is going to be about there, that means the power leads need to be about that long, so I need to cut them about there. So I'm going to start clipping wires and doing these solder pieces, and then we'll come back and have a look at what it looks like. So let me just show you very quickly how I've attached the ESC onto the flight controller. So I have soldered the power and ground wires onto the power and ground pads, and then all I've done is also stripped back the 3 wires that come out of it, the black, red and white wire that you'd normally plug into your receiver, and I've actually clipped out the red wire. We don't need that, that's there to supply 5 volts, and we don't need 5 volts. The flight controller is going to do all that for us. So what I've done is then I've just soldered that black wire onto the ground pad and the white wire onto the S1 pad. That's going to send the signal to the ESC and then put everything back together. Then with the ESC connected, it's just a case of reconnecting all of the ESC wires, and because we've put those little dots on, it should be easy. Having ESCs with these bullets is great because it means that when we come to test it in a moment, if it's going the wrong way around, I can just swap any two of these three wires and get it working the right way. So we're going to push the ESC into position, and then it's a case of removing the tape from the bottom of the ESC and putting that into position, and then just working my way around. So let's go to the final reveal and I'll show you how it's all gone in. So here it is. Let me show you how it all fitted in eventually. Now, pretty much everything went in exactly as I thought it would. So this is going to look very similar to what we've just described. Battery here at the front. We have the Walksnail at the front. Flight controller in where I thought it was going to go. GPS here and the receiver here. And then we have the little USB connector here at the side. The antennas for the Express LRS stuff I've put in there at the back on those kind of 45-degree angles. So the way it works is that as the plane banks, it's all going to be tickety-boo. The only disappointing thing I've had to do is put 15 grams of weight here at the back. I absolutely hate putting any additional weight into a wing like this that is dead weight like that, but I had no choice with a really heavy battery. Again, this battery is about 171 grams. The whole thing, including the extra 15 gram weight, is 393 grams. It's about 30-40 grams heavier than I really wanted it to be. But if I put my fingers under the CG marks, it will balance on my fingertips without a problem at all. So that is perfect. So the last thing we need to do then is we need to plug this into the computer. So let me take the prop off the back because we will eventually be plugging it into power. So with the prop off, we're about ready to plug this in and power it for the first time. Now, my advice would be, if you haven't powered it for the first time, triple check that all the connections that you've made are the right way round, that you haven't accidentally put a piece of wire in the wrong place, or you haven't bridged something with solder. The way I test it is I'm using a good old multimeter set to resistance. What I'm going to do, I'm just going to connect that over the two pins here in the plug, and what we should see is initially the value go low and then climb quickly. Just like that. That looks fab. Now I tend to also use something like this Vi-Fly smoke stopper when I'm doing this stuff. This allows me to turn the power on and off very quickly. This I think is the Vi-Fly smoke stopper or short saver 2. This is a fab piece of kit. If you haven't got one of these and you're going to do lots of building, get yourself one, because what it means I can do is I can plug it in here between the battery and the model. And although the little LEDs come on, it isn't powered, and then we can power everything at the touch of a button on here. And if something does go wrong and it starts to pull too much current, it'll automatically disconnect. I have got the USB cable plugged into this, so we can plug it into the computer, which we'll do in a moment. The other thing we need to do is we need to power up the radio, because we are going to be moving the controls on here.
Welcome to Edge TX.
And that is going to allow us to make sure that the control surfaces are both working in the right way. So now we've got all that in frame, let's jump onto the computer and plug this in. That's going to power everything. We haven't got the battery power installed yet, but let's connect. We can see that the GPS is live. Everything is very happy. What I'm going to do is I'm just going to go down to the Outputs tab, and I'm going to turn them on. And now, normally, if we keep the ESC protocol as standard, we are going to have to calibrate the ESC. I'm going to hope that this ESC understands D-Shot. So we're going to save and reboot and get ready to try that. It might not work. Some of the smaller ESCs that are supplied in modern wings do talk D-Shot. And if we're using D-Shot, we don't have to go through the calibration process. So that is ready. So let's power everything. So I'm going to power it on with the smoke stopper by pressing the button. And immediately the two control surfaces have popped up, and they should move as I move the controls around. That is looking really good, and they have settled into the position I want them, very slightly raised, and that's because we changed these midpoint values. If they're not in the right position, what you can do is you can just turn live mode on here and then change the numbers, and you will see the positions save. However, that looks all good to me. So we need to make sure that they're going in the right direction. The way to do this is really simple. All you do is you pull the stick down, and these should both rise so that the plane would rise in the air. And you can see here that that side is coming up and that side is going down. So this side is right, that side needs reversing. If you remember from the mixer and the way we've connected it up, that side is servo 3 and it's plugged into the servo 3 output here on the flight controller. So servo 3 is the one that we need to reverse. So what we're going to do is go into outputs, and then we're going to click on reverse for servo 3 and click save. And now when I pull the stick down, both of the control surfaces go up. Next thing we need to do is to check the amount of travel. For this model, 9mm is the maximum. So that means it goes up 9mm and down 9mm. So I would recommend doing this in manual mode, which is the middle mode that we set up last time. Let's flick it into that. And now
Good. Ready to fly.
we should see the movement. And that should be about 9mm. We can actually measure it by using just a ruler, and that's about 8.5. So this is looking really good. If we wanted to reduce the amount of movement here from these control surfaces, then what we could do is change the rate here, drop it down. So rather than be 100, we'd make it 80, and then that would be 8/10 of the current movement. But the way that the linkages are set up on this, that looks really good. Last thing we need to do is to see whether or not we can run the motor. So what we'll do here is we will go onto the computer and say we're going to do motor test. Again, I'm going to move the radio out of the way for this. And we definitely want to make sure we don't have the prop on. What I'm going to do is I'm going to click on I understand the risks. Let's see if one shot is going to work. No, it's not. So what we're going to have to do is go back to standard and do a save and reboot, because it looks like the ESC in here is going to unfortunately need calibrating. And that's not a disaster, that's a pretty easy job to do. That beeping that we heard, that 3 beeps, it was the motor that was actually making those beeping noises because it wasn't receiving a valid signal. Now, if we do the same thing again, we heard the 3 beeps confirming it's armed. What we can do is turn that on, and I can very slightly raise the master, and immediately the smoke stopper kicked in. But that means that this has started to work. We need to calibrate it now. So let's disconnect the power. What I'm going to do is I'm going to, with the main battery disconnected, I'm going to set the master slider to maximum. That's going to force the ESC in here into calibration mode. So let's power it up, and when we hear the beeps, we're going to drop this straight back down. So that should be calibrated. So as soon as I move this, we have it working in the right way. Let's just double check at very low power which direction it's going in. It's going that way, which is the right way for the prop. We are great. So the last thing we do, go into setup, and we can see here that all the stuff is green. We're actually in really good shape. This is going to arm, control surface in the right direction. The ESC is calibrated, the GPS is locked, everything in here on the right hand side is green. We're in a fab place. There's only a couple of things. Let me just disconnect the battery power while we play. Only a couple of things that I would recommend that we do now is I have tweaked a couple of things in here in preparation to fly. First one is in the PID tuning and advanced tuning stuff. In terms of the expo and rates, I've just increased the max roll angle to 60 and 60. I like to have a little bit more room for that. Things like the roll and pitch rate are going to be calculated when we do the tune. The only other things I've done is in the advanced tuning tab, specifically around things like the auto launch stuff, which I'm a really big fan of. I've increased the idle throttle to 1700. So what that means is that as soon as I take this to the field, and in the next video we'll do the whole maiden process and arm the model, this prop is going to start to spin at quite a high rate of knots. And the reason for that is this is quite heavy model, heavier than I probably would have liked to have it. 393 grams with that 3S lithium ion battery in the front. So I want to make sure that there's lots of thrust when I throw it. It has the best chance of climbing into the air. And I've tweaked a couple of other changes as well. This is how I tend to set my auto launch stuff up. There's only one last thing that we need to change, and that's in the configuration tab. There is something here called fixed wing level pitch trim. Now this is a slight offset because when a wing is flying, it doesn't fly level, it actually flies slightly nose up. Now this is going to be set as we fly for the first time. However, for safety, I am going to very quickly just set that. So if we get that value, pop that in. At the moment it's set to 0, so we will set that value as something like 4 degrees, which it probably doesn't need to be anything like that. And we'll save it. And what that means is that it's going to try and keep the nose 4 degrees up. That probably means it's going to climb.
GPS, good.
Now what that means is that...
GPS, lost. GPS, good. Ready to fly.
Let me
Receiver still connected.
Let me turn the radio off because it's just everything's a little bit too close at the moment. What we will do is when we go to fly, in the mode stuff, we will fly initially, we will launch, we'll go into horizon mode and fly around. We will then flick on auto level. That will then adjust that fixed wing offset that we just set to 4 degrees. We'll then continue to fly a little bit more. The continuously trimmed servos that we've set up at the bottom of this tab here is then going to trim the servos for manual flight. I'll put it into manual, make sure that's all working, and then we'll do a tune. It's a very, very defined process that I find personally works really well for me. So that is all of the things done. I can button this up and put the battery on charge and wait for a sunny day with minimal wind. So there's only one last thing to do as we have set up everything else, and that is to charge the battery, pop it in here, go to the field and give it a fly. So join me in the next video where we will do the maiden flight, and I'll take you through the things that I do just to make sure that everything's all going to work and that it goes off completely smoothly. So thanks again for watching the video, and I'll see you next time where we'll get this thing in the air. Thank you for watching the video. If you watch my videos and find them useful, then please take a moment to hit the like and subscribe button. It helps the channel a lot. If you really like what I'm doing here, you can become a Patreon and support the time I spend helping others and get access to lots of exclusive benefits. Link is in the video description. Remember that all the videos on the channel are organized into playlists, so you can easily use those playlists to find all the videos on a subject that you are interested in. Add Painless 360 to your searches on Google and YouTube, and it'll help you find my content for any particular topic. Thanks again for watching, and as always, happy flying.